Here, we are asked to find the surface area of this triangle PST. If this line QS bisects this angle PSR, we can see here that because of this right angle here, this triangle QRS and this triangle PRS are right angle triangles. So how can we solve this? How can we find the surface area of this triangle PST? Well, to find its area, we have to know what type of triangle it is. And for that, we need the length of the side. The length of the side also ends here. That means the sizes of the angles must be involved in calculating the length of the side. So let's find the sizes of the angles first. If you recall, from the question here, it says this line QS bisects angle PSR. That is, it divides it into two equal parts. So since this part is 28 degree, this is also 28 degree. Now from triangle PRS, based on the rule of the triangle that the summation of angles in a triangle is 180 degree, we can sum up its angles and equate to 180 degree. Here we have 90 degree, here 28 plus 28, which is 56 degree, and here this 23 degree plus this angle here, let's say x. So 90 degree plus 56 degree plus 23 degree plus x equal to 180 degree. 90 plus 56 plus 23 is 169. So 169 degree plus x equal to 180 degree. Subtracting 169 from both sides, x equal to 180 minus 169, which is 11 degree. Now from this triangle PST, since this is 11 degree and this is 28 degree, this must be 180 degree minus 11 degree minus 28 degree, because the summation of angles in a triangle is 180 degree. 180 degree minus 11 minus 28 is 141. So now we have the sizes of the angles we need. Okay, if you come back here, we can use the SOHCAHTOA tool to find the length of this side here. From here, this is the opposite and this is the adjacent. And here, this TOA means tan theta equal to opposite over adjacent. Theta is 28 degree, opposite is 8 centimeters. So tan 28 degree equal to 8 centimeters over adjacent. Making adjacent the subject, adjacent equal to 8 centimeters over tan 28 degree, which if you press a calculator approximately equal to 15.05 centimeters. So the length of this side here is 15.05 centimeters. Now still using the SOHCAHTOA tool on this triangle PRS, to find the length of this line PS, taking this angle as theta, theta equal to 28 degree plus 28 degree, which is 56 degree. So from theta now, this is the opposite and this is the adjacent, while this is the hypotenuse. So theta equal to 56 degree, adjacent equal to 15.05 centimeters, and hypotenuse equal to line PS. From this CAH here, cos theta equal to adjacent over hypotenuse. Substituting these values, cos 56 degree equal to 15.05 centimeters over line PS, which if we make line PS the subject, line PS equal to 15.05 centimeters over cos 56 degree, which if you press your calculator equal to 26.91 centimeters. So this line PS is 26.9 centimeters in length. Now from this triangle, since we have the sizes of all the angles and the length of one of each side, we can use the sine rule, which is A over sine A equal to B over sine B equal to C over sine C, to find the length of the other side. Let this side here to be A, this B and this C, but B we see is 26.91 centimeters, and the angle facing it is 141 degree. The angle facing side A is 28 degree and the angle facing side C is 11 degree. So now we have A over sine 28 degree equal to 26.91 centimeters over sine 141, we equal to C over sine 11 degree. Taking only this part here, A over sine 28 degree equal to 26.91 centimeters over sine 141. If we make A the subject, A equal to 26.91 over sine 141 times sine 28 degree, which if you press a calculator equal to 20.07 centimeters. So A equal to 20.07 centimeters. Coming back to this part here, 26.91 centimeters over sine 141 equal to C over sine 11. If we make C the subject, C equal to 26.91 centimeters over sine 141 times sine 11, which if you press your calculator equal to 8.16 centimeters. Now we have A equal to 20.07 centimeters, B equal to 26.91 centimeters, and C equal to 8.16 centimeters. Recall, by Heron formula, if the length of the sides of a triangle are A, B, and C, the surface area of the triangle is square root of S times S minus A times S minus B times S minus C, where S equal to A plus B plus C all over 2. Substituting these values of A, B, and C here, S equal to 20.07 plus 26.91 plus 8.16 all over 2, which is 27.57. Now substituting all the values here now, area of triangle PST equal to square root of 27.57 times 27.57 minus 20.07 times 27.57 minus 26.91 times 27.57 minus 8.16, which if you press your calculator, it will be equal to 51.4676. So area of triangle PST is equal to 51.4676 centimeters squared approximately, which is the area of the triangle we are asked to find. We are asked to find the circumference of the circle, and the data given here is that this point O is the center of the circle. This line AC here, a tangent to the circle at this point A here, and this line AB and line AC are equal, and hence triangle ABC is an isosceles triangle. And they say this angle BAO here is 4 times the size of this angle BCO here, so we can label this X, and if this is X, this must be equal to 4X. Here also, they said this angle ACO is 6 times the size of this angle here. So since this is X, this will also have to be equal to 6X. This line here, 9 centimeters. So how can you find the circumference of the circle? What's the formula for the circumference of the circle? The general formula for the circumference of a circle is 2 pi r, where r is the radius, and we all know that pi is a constant representing 22/7, so we can substitute it there. So to find the circumference now, what we need is the length of the radius. So if we look here, since this point is the center, this line AO here is a radius of the circle, because it was drawn from the center down to the circumference. To find its length from this triangle here, we will need the length of one of the two other sides of the triangle, and also the sizes of at least 2 interior angles of the triangle, though we don't have any. But from this triangle here, triangle ABC, since we have the length of this line BC here, you can use it and find the length of this line AC here if we have the size of the interior angles. But what are the size of the interior angles? That's what we are going to find now. This angle here is 4x, this here 6x, and this is x. But what is this angle here and this angle? Recall, they said line AB equal to line AC. So that means this angle here and this angle here are the base angle of the isosceles triangle ABC. And we all know that the base angle of an isosceles triangle are always equal. So therefore, this angle here and this angle here are equal. So since this is 6x and this is x, this must be equal to 6x plus x, which equals to 7x. So we are still left with this angle here. So since this line AC is a tangent to the circle at A, there is a rule that says the tangent of a circle is perpendicular to the radius through the point of contact. So that means this angle here is a right angle, meaning 90 degrees. Now considering triangle ABC, since this here is 7x and this here 6x and x, and here 4x, this here 90 degrees, we can form an equation that 7x plus x plus 6x plus 4x plus 90 degrees equal to 180 degrees, because the sum of angles in a triangle is 180 degrees. 7x plus x plus 6x plus 4x equals to 18x. So 18x plus 90 equal to 180. If we subtract 90 degrees from both sides, 18x equal to 180 minus 90, which equals to 90 degrees. So 18x equal to 90. Dividing both sides by 18, 18x over 18 equal to 90 over 18. Here 18 cancel 18, and here 90 over 18 is 5. So x equal to 5. So since x equal to 5, this angle here equal to 5, while here 6x will be equal to 6 times 5, which is 30 degrees. Here 4x equal to 4 times 5, which is 20 degrees. And here 7x equal to 7 times 5, which equals to 35 degrees. So now, to find the length of this line AC here, we can use the sine rule. So using the sine rule, line AC over sine 35 degrees equal to 9 over sine 110. Making line AC the subject of the formula, line AC equal to 9 over sine 110 times sine 35. Sine 110 equal to 0.9397 and sine 35 equal to 0.5736. So line AC equal to 9 over 0.9397 all multiplied by 0.5736, which equals to 5.4937. 5.4937 is approximately equal to 5.5. So line AC now here equals to 5.5 centimeters. So now to find the length of this radius here from this triangle here, triangle AOC, since it is a right angle triangle and an angle is involved, which is this angle here, we can use the SOHCAHTOA. So from this angle here, this is the opposite and this here is adjacent. So here tan theta equal to opposite over adjacent. Theta is 30 degrees. Opposite is line AO and adjacent is 5.5 centimeters. So tan theta equal to line AO over 5.5. Making line AO the subject of the formula, line AO will be equal to tan 30 degrees times 5.5. Tan 30 is 0.5774. 0.5774 times 5.5 is 3.1757. So therefore, the radius of the cycle equals to 3.1757 cm. Now coming back to this our equation here, which says circumference equal to 2 times 22 over 7 times r. Substituting r equal to 3.1757 here. So circumference equal to 2 open bracket 22 over 7 all multiplied by 3.1757. Press your calculator equal to 19.6915, which approximately equals 20 centimeters. So we found the circumference of the circle to be equal to centimeters approximately.